Hi, I'm Ozan Unal, and I'll be presenting our work, 4 Ways to Improve Verbo-visual Fusion for Dense 3D Visual Grounding. 3D visual grounding is a task of localizing the object in a 3D scene which is referred to by a natural language description. A common formulation to tackle 3D visual grounding is grounding by detection, where localization is done via axis-aligned bounding boxes. While such a detection-level grounding has vast potential for real-world applications, ranging from autonomous driving to robots to AR/VR, the level of geometric detail which is provided by a 3D bounding box detection remains limited. As an example, autonomous robots may have to grasp or avoid objects. Therefore, delivering a detailed point-wise mask is more beneficial for downstream tasks than having just axis-aligned bounding boxes. We therefore explore the problem of dense 3D visual grounding, in other words, referral-based 3D instance segmentation. Starting with a natural language prompt and a 3D scene in the form of an RGBD point cloud, we build a baseline model following the commonly used grounding by selection strategy. Firstly, the two modalities are encoded separately, where a verbal backbone processes the natural language prompt, while a visual backbone produces 3D instance candidates with a point cloud as input. After that, a Verbo-visual fusion module selects the correct candidate based on the natural language embeddings. In our case, we leverage a kernel-based 3D instance segmentation backbone. With this framework, we observe that 3D instance segmentation yields a more robust and tighter predictions compared to 3D object detection, but suffers from reduced separability in latent space between instances of the same semantic class. This results in a significant increase in false positive rates for higher-level 3D visual grounding tasks, most notably observed for repetitive instances, in other words, instances in the multiple category that are not semantically unique within a scene. To combat this effect, we propose 4 novel ways to improve verbo-visual fusion for dense 3D visual grounding. First, we observe that in cases where referrals may be construed as valid for multiple instances, locality rules. While a given cue might be valid for multiple objects within a scene, due to our limited attention spans, humans often capture verbal relations between neighboring instances. However, such localized information routing is difficult to learn for global attention schemes. Inspired by the effective windowing in NLP and 2D applications, to disambiguate inter-instance relational cues, we propose a bottom-up attentive fusion module, BAF, that induces this locality during verbo-visual fusion via spherical masking, with an increasing radius allowing only neighboring objects to attend to each other. Second, we observe that instance kernels from our visual backbone show less separability in the latent space compared to box features. To form a general solution to the feature separability issue, we construct a contrastive training scheme to alleviate ambiguities between embeddings of repetitive instances. Specifically, we pull sentence embeddings in matching instance vectors towards each other while contrasting non-matching pairs. Next, we tackle the issue of view-dependent referrals. Unlike in 2D, 3D scenes do not inherently possess a directional right or left, or a room does not have a clear back or front. However, our perception is often guided by our personal perspectives, and thus such view-dependent descriptions are unavoidable in any real-world situation. While we can empathize with a speaker and rationalize the possible viewpoint associated with an utterance, this trait does not come naturally to machines. We therefore propose to introduce a Learned Global Camera Token, GCT, that can be directly supervised via the camera positions used during annotation to help resolve view-dependent prompts. As our final contribution, we improve the quality of our predicted referred instance mask through ensembling over multiple views of a single point cloud by reducing the epistemic uncertainty. Now, due to the variations in the input point cloud under different yaw rotations, the predicted referred masks may vary in 2 ways. The selection may vary where not all forward passes may generate the instance mask of the same object, or the segmentation results may vary where, even if the same object is selected, the set of points defining the mask might be different. To this end, we develop a 2-stage ensembling algorithm for dense 3D visual grounding that first determines the correct referred object from all predictions of the individual viewpoints, and then refines the aggregated instance mask. Finally, we construct our model ConcreteNet by introducing our bottom-up attentive fusion module that aims to disambiguate inter-instance relational cues, including a contrastive training scheme to induce separation in the latent space, resolving view-dependent utterances via Learned Global Camera Token, and employing multi-view ensembling to improve referred mask quality. ConcreteNet ranks first on the challenging ScanRefer online benchmark, and has won the ECCV's 3rd workshop on language for 3D scenes 3D Object Localization Challenge. Thanks for listening, and make sure to scan our QR code where you can find our paper alongside our code.